I don't know if I'm changing over. In the moonlight, I can't kill this feeling sober. So it starts to come alive. I don't know what starts to control me. I let it go, another soul that's underneath. I don't really care about this all. It's the fall that kills me. With our back against the wall, just feed the beast and you'll see. Wait for me. I don't die inside my reality. Wait for me. I don't want to remember me this way. I feel like that we're getting closer to a brand new night. The past is finally getting over. I really think it's time to say goodbye. I don't know what starts to control me. I let it go, another soul that's underneath. I don't really care about this all. It's the fall that kills me. With our back against the wall, just feed the beast and you'll see. Wait for me. I don't wanna die inside my reality. Wait for me. I don't want you to remember me this way.
The world is full of inspiration. It just depends on how you spend it. Whatever inspires you, you gotta grab it and make something.
Hey folks, how you doing today? Oh, sorry, I missed more ads. My goodness, maybe we can just mute that here. Alright, it is Wednesday. It means it's data structures night. We're going to talk about stacks here. From chapter 5 and 6, and then inheritance and polymorphism, along with the solution to project 1, before we get into our project 2 tonight. So we got a little bit on tap. Not too bad. Oh, I'm sorry. Yeah. Project 1 shouldn't have been too bad. Yeah, I mean, it's a decent amount of work to do some of the menu stuff. But in terms of just using the bag, hopefully that part wasn't too bad. All right. So we'll start with that then. Look at the assignment. Let me fire up NetBeans here. NetBeans, come on. There we go. All right, this is probably done. There we go. Still on an ad? Oh my goodness. More ads. So it's all rubric based, so you can definitely get partial points here. Anything that you have here. All right. Okay, if they didn't mention it, then that's fine. Come on, rubric. Everything is slow when I load these. Yeah, shopping cart, shopping cart, shopping cart, shopping cart, shopping cart, item class, item class. Test the shopping cart with the bag array. So either in main or with the unit test, right? If you wanted to do unit testing, great. If you want to just have a main method, I was fine with that because we haven't talked a whole lot about unit testing yet. We'll save that for this next project here. Yeah, just confirming that it works, right? Okay, yeah, that's fine then. Yeah, and testing your shopping cart with the bag of linked objects or the bag array, fantastic. Either way, should be in pretty good shape. Come on, NetBeans. It knows it's a Wednesday. Does not want to cooperate. It'll be a short night and this just won't load at all, right? Downloading modules. There we go. All right, I'm just probably done with ads now. Yep. All right. All right, so we'll do a new project. What is my computer even doing? Oh, I have the stream manager open. That's why. This thing just hogs resources when that's open. That should not be there. Sorry. Hopefully that'll speed things up a little bit, maybe. Like, what is so slow? I'm sorry, Hirishi. Yeah, definitely reach out. That's why all the projects you have 2 weeks to work on them, right? Ideally, you get started, and then if you get stuck on something, let me know. I'm here regular office hours Mondays and Wednesdays, 3 to 4:30 and 10 to 11 p.m. and also by appointment if those times don't work for you. Just send me a couple times and see if we can't make 1 or 2 of them work. Yeah, it's just NetBeans is slow. Just NetBeans hates me. All right. Still, like, it's empty. There we go. What are you doing, NetBeans? It's using so much CPU. All right, now we're a little more stable. So let's start up a new project. Java with Ant. Let me make sure I put it in my 2353 repository here. We're in the right class. This is project 1. Oh, you know what? I'll just copy them over. That's fine. I had some of those ADT bag things already, so we have that project as well. But we need to copy some of those concepts over. We wanted our bag array, the bag interface, and the bag of linked objects, and the shopping cart, and the item, right? So come over here and paste them in. Refactor copy. And that should change the project name if we did it right. Let's see. Yep, project 1. All right, awesome. Shopping cart, bag interface, right? Yeah, it's there. Project 1. Let's try and maybe it just needs to build. There it goes. Yep, just needed a minute. We had our linked objects. We had the bag with the array backing, and this one was resizable. The linked objects, I forget, I'm sorry, I'd have to go look at your name again. Someone did find a bug where I was not reducing the number of items in remove. So then that would make the to array fail, which was really sad, because it goes through the number of items. So hopefully you saw in Discord, I posted the update for that. And we should be in good shape. I wonder, Professor Perp, I wonder. If only I could remember. I have a terrible memory. I mean, maybe they'll turn up and claim their bonus points. So, okay. So our shopping cart, right, would accept a bag, which is a type bag interface. So it doesn't care if it's the array bag or the linked objects bag, right? It's just going to take either one because they all have the same methods here, and we'll work them, right? Whichever it is. So then let's take a look and see what other pieces we needed to have here then. Right, so this is add item to the cart, remove an item, remove a specific item, get a count of the number of items, abandon the cart. Sure. So we have this bag. This is for storing all our items. So then I can have a public item, remove item. And it's just going to return bag.remove. Right? Just ask the bag to remove one. Sure. And a public void remove item that accepts an item to remove. So if you tell me what item, I'll take that one out of my cart. Right? The idea that the person using shopping cart doesn't care how we're storing these items. Right? This idea we're interacting with this public interface, with these public methods here. So sure, we're good to go. We'll make a shopping cart either with an array or linked objects. We can look at other ones later on, other data structures for storing things. We'll just add remove. So if you want to remove a specific item, we're going to call bag.remove given the item. Right? Ask the bag to remove the item. And now did bag remove an item? Okay, that gives us back a true or false. Maybe we give back a true or false. Sure, why not? So then we can just return the same thing, whether or not we get the true or false. It was removed or not. Okay. How about a public int get number of items? Returns bag dot get current size. Right, how many items are in the bag? This is how many items are in our shopping cart. Cool. Abandon the cart. Right, essentially clear the cart. Sorry if that was a little bit awkward. Void abandoned. Bag.clear. Clear. Right, clear the bag. That bag interface had a clear method. It would just take everything out. Right? We abandoned it. We left it for some poor sucker to put away. Right? I don't condone that behavior. Don't recommend it. It just upsets our clerks. Okay, so that's our shopping cart. Okay, right, our item class include a name and price, and add an equals override method that returns true if the name and price match. Okay, so let's take a look at item. Right, this was empty right now, it was a placeholder. So we need to have a private string for name, and a private, probably a double for price, right, because it's got decimal places, so probably a double. And then we want a constructor, right, for item. Let's see, didn't specify, but you probably want to have a constructor and set methods, get methods maybe. I'm not a fan of set methods usually, like because once you set the name and a price, like with the constructor, you probably don't want to change it again. Maybe setting price is probably fine. Either one, but I'm going to go with the constructor. You know what? We can do all of them. Why not? So let's do insert code here. Right? This is one of those pro tips. You get a constructor that takes a name and a price, sure, and it gives me a constructor that takes a name and price. Insert code, insert a getter for name and price. Fantastic. And then a setter. How about we just do set price? Because once you set a name, you're probably not going to change the name of the item. So we'll just have a set price. Okay? Awesome. Now in here, some sanity checking might be nice, like make sure you don't have a negative value, that sort of thing. That's probably above and beyond, but it'd be nice to do. And that's the place where you do that in your set methods, right? To do some sort of sanity checking. Okay, now we need an equals override method that returns true if the name and price match. So if it's overriding, remember we need to compare versus object. So we add an override for public boolean equals. Now with the override, this has to be a type of object. Other. If it's not an override, you can accept another type of item here. And I'm trying to remember. I don't know if we actually did that one or not. I don't think we did the override for it, did we? That's our interface. Where'd it go here? Did we do an equals in here? Override. I'm trying to remember now. Maybe we did it in a different project. That's okay. So first we need to compare. So if you didn't do the override and you just did it versus another item, I'll be fine with that. But you know, this is better. So we need to check if the others get class is the same as this get class, right? Or my get class, right? If our classes match, then we're good. Or so really, if they don't match, we're going to return false right off the bat. So if we're not the same class, we can't be equals. Otherwise, then we'll have the other item equals, we'll cast of type item, the other object. Right, so if they don't match, false. If they do match, then sure, I can cast this object as a type of item, because it is an item. And then I can return if my name dot equals, probably ignoring case, right, the other item dot name. If those match, and my price matches the other item dot price. Other item dot price. Not private. Price. There we go. Price. Okay, so we'll compare. Hey, do our names match and do our prices match? Oh, baby. Oh, is Jack being mean to you, baby? You can come hang out with me. Say hi. Say hi to everybody. He's looking bigger already. Not so much like a baby cat anymore. He's getting lanky. Here you go, buddy. You can stay safe up here. My little guy, he loves the cats, but he just wants to hug them, and it just like basically flops on top of them, trying to give them hugs. Poor kitties. Okay, so that's our equals method for item. And that's the override version. If not, that's okay. When adding an item, ask for the name and price, add that to the bag, tell them if it's successful or not. It should always be successful, right? The original bag array here, before we were resizable, before we had this increased capacity, couldn't do that. So if you didn't get the latest and greatest version of this, if you're just using the fixed size bag, that's okay. Then you would tell them, no, your cart's too full, right? But for now, essentially, our carts are limitless. They're bottomless carts, which is not the case with my 6 kids. When we go to Costco, we're a 2 shopping cart family at Costco. 2 shopping carts at Meijer usually, unless I'm going every other night or something. So, but sure, ours is limitless. We can just put as much stuff in as we want to our cart. Okay, you with me so far? So we've updated item, we've updated shopping cart. If you remove an item, tell them it was removed. Okay, add a method for getting the total cost of the cart, and add a method for printing a receipt, which is the item cost and the total cost at the end. Awesome, so let's go to shopping cart, and let's add, sure, we can put it up here, why not? A public string receipt. Right, so we need some sort of result. We should probably use string builder here. The string builder, builder equals a new string builder. This is the proper way to build strings. Because remember, if you have a string and you append to it, it's making a new string in memory. And if I have 100 things in my cart, that means I've made 100 different strings, one bigger than the next, over and over and over and over and over, and I keep throwing them away. That's just a waste of processing power and cycles in Java. So string builder is mutable. It lets you add more things to the buffer, and then you're in better shape. So we're going to say for, we need an object array, and a bunch of people have this problem. The best I can tell, Java is just stupid, and you have to make this an object array to use the toArray method. So this is our result, is my bag.toArray. It knows it's type item, but it doesn't let me save it as type item here. It's just dumb. So that's what it is. Sure. And then we can say now for object item in result, we can cast it. And this is what we looked at last week here with the ADT bag. Right? You can go through and you can cast them one at a time. Here. So we're just going to cast it. So here's the, maybe we'll just call it, I want the word item. Shoot. Object. Why not? That's That's terrible. So item equals casting as type item, the object. Then I can take that item and I can add it to my receipt. Is that how you spell receipt? That might not be right. And if you're going to be turning something into a string a lot, you might as well add a toString here. Right? Public string, string, toString, return what? The item name plus price. Probably with a space here, right? Sure. Name and a dash in the price, or name and price, I don't know. Something like that's probably fine. So then for each item, we can take our builder and we can append our item toString. And then we can take our builder, we can append, how about, I don't know, this is a receipt, so probably a new line, right? So we'll just add in our own new lines here. That'll add every item to our string builder here. Then what we need at the end is the total, right? So we'll take our builder, dot append, total. And then we need a method for get total cost, right? So public double get total cost. Again, just do this object thing here, essentially. So we have a double for total. Starts off at 0. We'll loop through every object in there, taking total plus equals the item.getPrice. Finish the for loop and return the total. Right? No, this is nothing new, getting totals of objects, right? Or of things out of an array, essentially. We just have to do this extra step of casting here. We have total, and then we'll take builder, dot append. How about string.format to make this pretty, right? And we can format in here 0.2d for decimals, floating point numbers, with get total cost. And then we can return builder.toString. Right, that's how we finish with a string builder. Builder toString. Okay? Here, okay, we can do this all in one line here. I like this. We'll take the total, throw that in here. Right? There, now it's all one line. That's prettier. Instead of having to do two different appends. I like that. So total and the total. Probably add a $sign, right? Okay, so now we can get a receipt, we can get total cost. I think we got receipt, we get total cost. Yep, total cost. We can remove an item, right? Ask a name and price, try and remove it. Cool. That's the rest of this console application, right? If you did unit tests, great. If you didn't have the unit tests, then I'd expect the console application. All right, so then we probably need like project 1 here. So this is the part that is going to interact with our classes. Now you'll notice none of these classes here have anything to do with system.out.println or using a scanner object to get keyboard input using the standard in. Right? The class should be portable. The class shouldn't care if you're going to use it in a console-based application or a web application or a mobile application or a graphical user interface application. The class should be portable. So you have public methods to interact with the class. Right? So, okay, so let's figure out how we can do it with a bag that is an array-based bag or a linked objects bag. Right? Maybe we ask the user. So sure, so we'll use scanner keyboard, give a new scanner, given system.in, and then we'll ask them. Want to use an array bag or linked object bag today? Sure, why not? And then a string for bag type. Keyboard.nextLine. Oh, Java didn't import, so we need to add the import for java.util.scanner. Fantastic. So we got our imports. Okay, so now we have our bag type, and we can say if bag type is equal ignore case. How about array bag? Right, then we'll have an array bag. Sure. Right, otherwise we'll have a linked object bag. We could do that. Right, so this is a bag interface bag. Bag is new array bag. Oh, bag array? Oh, okay, I'm backwards then. Oh, okay. Otherwise, bag is a new bag linked objects. Cool. And then we can make a shopping cart. Shopping cart. Cart equals a new shopping cart. Given the bag. Right? Shopping cart doesn't care. As long as it implements this interface, right? As long as it's a class that implements this interface, we can use it here in the constructor because it asks for anything that is this type of interface. Ooh, of type item. That's right. Of type item. We got to include that. I forgot. So it's a bag array of type item. There we go. That's going to be important. Bag interface of type item. There we go. That should be happier now. Okay, so now we're a bag of type item. Right, that's our generics here. Right, you give me the type here, and we're good to go. We'll use that type everywhere we want the T type here. Okay, and then we're going to ask them, right? So now we're going to make some sort of loop, right? So, I don't know, a string for, again, I don't know, or keep going, or stop, I don't know. Stop equals no, I don't know. No. And how about while stop that equals ignore case? Yes, and we'll say not. Well, it does not equal yes. Let's keep on going, and eventually we'll ask them, do you want to stop or keep using the shopping cart? And then, you know, typically you tell them like yes, no, like give them some sort of hint here. All right, and then we can say stop equals keyboard.nextLine. Oops, yeah, so if they say yes, we should stop, the whole loop is done, right? Sure, that was fun. And maybe when they're done, maybe then we print out the cart, right? When they're all done, or maybe that happens inside the loop, I don't know. The program probably just ends here, that's probably fine. All right, so then we need to ask them what do they want to do. So we'll have a string for option, and we'll say, oh, that should probably go below. Welcome to your shopping cart. What do you want to do? And then maybe we'll give them some options, right? Like add item. Sure. What if we make it like menu style? Like how about 1 for add item? That's usually pretty easy, right? How about 2 for remove item, or remove what? Random item. It's not exactly random, but sure, we'll call it random enough. Remove specific item. How about a, I don't know, what else we're going to do with cart? Let's see. Add item, remove a specific item, get the count number of items, and abandon the cart. Okay, so get number of items in cart, and abandon the cart. Sure. Why not? And we'll have an option is keyboard.nextLine. Next line. Okay, and then we can check, hey, if it was a 1, 2, 3, 4, or 5, let's do something. Right, and maybe we keep on going, right? Maybe we stick them in this loop until we get a 1, 2, 3, 4, or 5. We could do that, right? This could be a loop. Yeah, it's probably the equals method in the item class. We could take a look at that later, Hayes, for sure. Right, so if we've got some sort of menu here, right, we want to make sure that we're stuck in the menu until they give us a valid result. Right, so if it's not a 1, 2, 3, 4, or 5, we want to stop. I'm sorry, if it is, we want to stop the loop and keep on going. Yeah, double equals won't cooperate. Were you saying that the double value? So like comparing one double to another double? That should have worked, but you know, we can take a look. We can take a look and see. Oh, the little guy fell asleep. He was tired. All right, so Sure. Let's why not? We'll do this as that's ugly. While I don't have to list them all out either. That's ugly. And I guess we're gonna have to do it. So we'll say string option equals blank to start. And then how about while option dot equals, and now this is a number here, so there's no case to compare with. Right? So it does not equal 1, and does not equal 2, and does not equal 3. Oh, this is kind of ugly, but that's okay. And does not equal 4 and 5. 2, 3, 4, and 5. Curly brace. Oh, not there. Curly brace down here. There we go. So as long as it's not 1, and it's not 2, and it's not 3, and it's not 4, and it's not 5. Ugh. I don't know. Let's put 2 there. Maybe we'll do. I feel like that. Okay. Still kind of ugly, but it'll do. Right. So you're not a 1, and you're not a 2, and you're not a 3, and you're not a 4, and you're not a 5. Keep on sticking them in this loop here. Okay. Once this is no longer true, so if any one of these does equal, then not equals is false, and if anything in an and is false, the whole thing is false. Then the loop will stop. Right. Now we have an option. Okay, so then we can say if option dot equals 1. Sure, what are we doing? We're adding an item to the cart. Okay, so we need to ask him for an item. Right, where's my curly brace? There we go. So we'll have a string for name, right, and a double for price. That we need to go get here. Okay, so we'll ask him for the item name, and name can equal keyboard.nextLine. And enter the item price. And this can equal double.parseDouble. Right, you want to convert here. Double.parseDouble. Sorry, capital D. Double.parseDouble. Keyboard.nextLine. Now we have an item. Equals a new item. Given the name and the price. Right, using that constructor or the set method. Either one's fine. And then we can add that item to our bag, our shopping cart. So our shopping cart dot add item given the item. Fantastic. Can you use comparison operators with the equals method? No. Nope. You mean like greater than and less than? So typically you'd use compare to. There's a compare to method that gives you a negative number if it's less than, a positive number if it's greater than, and 0 if it's equivalent. That's the compare to or comparable interface. It's typically what you use for objects. You wouldn't use the less than or greater than operator, or the relational operator there. Okay, cool, so we added an item. And again, I know ours are always going to work. So sure, we added the item to the cart, no big deal. Because we don't have that fixed size here. Okay, else if option equals 2. Okay, well, this is removing a random item. Sure, so we're going to print removed shopping cart. Nope, sorry, cart dot remove item. Great. Remember, remove item removes, gives me an item back. Right, when I call remove item, gives me an item back, and item can be two-stringed with name and price. So it should just remove right off the bat and print it out. Else if option equals 3 here, well then we need to figure out the name and price, get the item, and then we're going to try and remove the item. So we can try if cart.remove item, given the item. If that's true, we're going to print remove successfully. Otherwise, we can say couldn't find that item in the cart. Right? Yeah, if you wanted to use setters, so you'd instead of using the constructor here, you'd say item equals new item with no arguments, and then it's item dot set price with the price. Again, we didn't have a set name, so we didn't bother. Sure, I'm not a fan of JOption pane at all. You must have had a class with somebody else who was, and I can guess who that was, but that's okay. No, not a problem. Again, it's kind of awkward for typing if you're at a console application, because then it pops something up at you. But sure, that's fine. I'm just not a big fan of JOption panes. Alan, I thought Alan hasn't been teaching for like a year. You must have had a little break between classes then. Okay. No, JOption pane is fine too. Not a problem. All right, my guess was wrong then. I guess you get some points, Mizuki. Because my guess was wrong. You can have like 10 bonus points. But, you know, they're not actually worth anything, so sorry. All right, and else if my option equals 4, quote 4, oh my goodness, that side, quote, that quote 4. There we go. So that was get the number of items in the cart in 2017. Okay, yeah, he was definitely teaching in 2017. So we're actually hiring his replacement. The new faculty member is going to start in the fall semester. Really excited. Technically, I took over for Professor Schanneberger when he retired the year before Mr. Jackson retired. Apparently, it takes a while to replace somebody, but academia is just a weird place. Everything is slow in academia. It's just a weird, sad, slow place, but that's okay. All right, so if it's 4, we're going to print, you have, I don't know, we can just, let's do a string format. That's prettier, right? String.format. You have, I know this is percent, oh, it's D for digits. I'm backwards here. D for digits, and this one here is, where did we do this before? The receipt here. F for floating point number. D for digits. Yeah, that wouldn't have worked. F for floating point numbers. I hate these percent Ds. Yeah, percent D digits, items in your cart, given cart dot get number of items. What am I missing? Another parentheses. There we go. Give it a little format. And else if option equals 5, cart dot clear. Was it not clear? Oh, abandon, right? Cart dot abandon, sure. And print out, you abandon your cart should be ashamed. But sure, empty their cart. If else in a switch? I don't think so. I really don't like switches because you have to remember the breaks. And then you can't really, and you can equals ignore case, sure, you could do that. Yeah, I don't know. I'm just not a fan of switches, but it's fine if you use it. Not a big deal. All right, so I think we're good here then, right? So that was 3, that was 4, that was option 5, and that was it, right? And then we ask them, hey, do you want to stop using that? What is this? That's all in the stop. Oh, so that needs to go there. I had one too many curly braces. Option, and then we'll ask them if they want to stop or keep using the cart. Sure. Okay, how's that? You can abandon it. Item class. Getting total cost. Oh, printing the receipt. That's right. So the receipt option. Let's just do the receipt after we're done. Or how about checkout? So do you want to check out? Yes or no? If they say yes, then we'll go check out and we'll print out the shopping cart dot receipt. Cart dot receipt. Receipt. There we go. Okay, let's give it a try. All right, let's use, how about the array bag for fun? Let's add an item. We'll add apples for $1.50. No. All right, let's add an item. Let's add, how about some sushi for $6.50. $6.50. No. Let's get the number of items in our cart. 2 items in the cart. No, don't check out. How about we add another item? Let's add some chips here for $2.50. Check out no. How about we remove a random item? Oh, we removed our chips. Okay, sure. Don't check out. Let's go add an item. Let's add. How about popcorn? That's probably what, $3. Check out no. How about we remove a specific item? Let's remove those apples that were $1.50. Remove successfully, and we'll check out. We got popcorn and sushi still left for $9.50. Okay, so we were able to test it out. And it seemed like it worked okay. Right? Or now we can also try the bag of linked objects. Sure. So let's run it again. Try the bag of linked objects. Linked object bag. Sure. Add an item. Add chips for $1.50. Get number of items in the cart. We have. Oh, sorry. That was get number of items in the cart. We have 1 item in the cart. Check out no. How about we abandon the cart? We abandon the cart. We should feel bad about ourselves. Check out no. Get total number of items. There's no items in the cart, right? It's empty. Sure, we cleared it. Check out no. Let's add an item. How about we add those apples back for $1.50? And check out yes. All right, we have apples for $1.50. So it seems to work with either. All right, how you folks feeling? This sort of makes sense? Feeling okay? Hey, don't fall down, baby. Don't fall down. He's sliding off my lap. Cool. Seems good. Any % shopping cart Java code speedrun? Feels good? All right, Ray. Cool. Yeah, this is in the repository. I'll commit it here in just a second. Thanks for reminding me. Yep. Exclam GitHub there if you need the link for my GitHub. Not my Lab2 template. This one is 2353. There we go. So this is Project 1. See all the Project 1 stuff, all the Java files. Life is good. Oh, you know what? I need to set a good example for you folks here. I'm going to go to GitHub, go to my repository, and go to my ADT bag here. Source. Sure, I could use each of these. Sure, why not? Bag interface. And I'll come over to bag interface, and I'll say copied from, boom. Again, I told you that was fine, right? I was expecting you to do that for this project. But if you got something that wasn't mine, right, that would be your citation here, right? And again, put this in for all of them. Sure, why not? You know what? I don't even care right now. But that's how you would cite a source, right? Commit and push. Okay, so that should be out there in the repository for you folks for later. All right, I can close these down. Close those down. I mean, I was expecting you guys to copy that one, so I wasn't asking for it this time because I said go use it, and like that was even in the directions here. Where is it here? Like, see GitHub repo, for example, and like go see it here. So I was expecting that, but if you find someone else's code and you're citing it, right, just drop a comment with the URL there, and we're cool. Right, that's the proper way to cite your sources. All right, so for the rest of the night, we'll have stacks to talk about from chapters 5 and 6. We'll have inheritance and polymorphism from interlude 7. Unless I got those backwards. I think that's the correct order here. I'll double check. I think I mentioned I've got all the book PowerPoints for you folks now. I found them from last time I taught, because they only have the new ones online, which is crazy. But got them all out here. Interlude 7. Yeah, Inheritance Polymorphism is Interlude 7. And chapters 5 and 6 are about stacks. Stacks and a stack implementation. Okay? So that's what we'll go over tonight. No, I don't usually do retakes for projects, Rishi. But you'll have other projects to work on. And, you know, they all have 2 weeks. So definitely get started early on the projects. I got a surprising number of questions yesterday and today about the project. If you look at your old project to see how to do things you forgot. Well, the stuff you were doing in old projects was probably stuff right out of the textbook. And again, I don't expect you to cite the textbook either, because that is your main reference. And like everything you've learned is probably out of the textbook, or maybe something I said, depending on how much you actually pay attention to me. So I don't expect that. You know, unless you're like, you know, exactly letter for letter taking something out as a direct quote. Yeah, then you could cite it. But if you're just, hey, here's how you do a method. No, there's nothing to cite there. Okay. Hey, baby boy. Java puts my cats to sleep, apparently. It is that boring. He doesn't care about shopping carts. Unless we put cat food in there, right? He does like his cat food. Hey. Here, are you waking up again? Alright, cool. So let's start up a new project here. And we'll talk about stacks. Hi, baby. So stacks are going to work. You know what you'd expect a stack to work like. Yeah, the self-assessment. Yeah, copy paste. That'd be ideal. Until you tell me whether or not you got the point. Yep. So you could just go through the rubric and say either, you know, by number, say the first thing, the second thing, the third thing, or just copy paste the lines out. Unfortunately, it's not interactive for you folks, but it is interactive when I go to grade your assignment. I just got to click yes or no on the scale, and it assigns points or doesn't assign points. It's pretty cool. So I'm a big fan of using rubrics. But for the longest time, I would use them, and then people would wonder, like, oh, how did I do in the project? Before I got a chance to grade it. So I've started asking people to self-assess themselves using the rubric, and that's the reminder, oh wait, there's a rubric here, and these are how I get my points. Hopefully to drive that point home, and then you'll feel better, like, oh yeah, I met all these objectives, I'll get my points, or, oh sure, I got like 2/3 of them here, so maybe I'll get a couple points, that sort of thing. Hey. Oh, he's a sleepy guy. I know. You're gonna fall asleep on my laptop? Alright, but I got it. You're distracting me, kitty. You're too cute. Alright, so a stack here, right, as you can imagine, say you have this nice little table here. Right, here's our table with some legs, and there's probably another leg we can't see over there. Maybe it comes down to there, right? Sure. Here's our nice little table. When you put something on a stack, all right, yeah, I'll hold up the camera again. You know, twist my arm, make me show off my little kitty. Say hi, baby. Say hi. Now show him your big paws. He's got 6 claws. He's got that extra claw. Okay, you don't want to do that? I'm sorry. He doesn't want to show off. I'm sorry. Yeah, the toggleable self-assessment would be really cool. That'd be a nice feature of D2L. All right, so imagine this is my table, right? And you put something on the table, right? So you put a little book on here. Okay? We put a textbook on. If you're going to make a stack of textbooks, right? You can put another one on top of that. And you put another textbook on, put another book there, and another book there, and another book there. Sure, you now have a stack of textbooks. So when you go to put something on a stack, where does it go in the stack? Right? Well, it goes on top. It goes on top of the stack. You put another book on. You put it on top of the stack. Okay? If you go to take something off the stack, are you taking this bottom book down here? No. That's just a recipe for disaster, right? We don't do that. We don't take the bottom one. You take the top thing off the stack. You say, okay, stack, take the top thing off. So we take that top book off. Great, we took it off. Now we have a book. And then we can take the next one off. Maybe we'll take the book, put it over here. Okay, now I took that book off. Okay, I'm working my way down through the stack. So stacks are essentially a very simple way of storing data. You push something onto the stack, right? You pop something off the stack, or you can peek at the top thing. So peek will return a type of T, pop will return a type of T, and push, you need to push a type of T onto the stack if you want to use these generic types. Right? And that's the only thing we do with the stack. Right? You push something on, you pop something off, or you peek at the top thing. Maybe you might say like is empty, right? You could do that. Is empty, right? That would be a boolean. Oh, that's probably the wrong direction, isn't it? That should be colon boolean, colon T, colon void. Right? If we're following our nice UML project 1 in the repo, it should be right there in the project 1 folder. If you go back, it should be project 1. Yeah, right there from 8 minutes ago. Okay, so that's how we interact with the stack. It might know how many items are in it. Maybe it does, maybe it doesn't. I don't know how important we want to call that, but I guess we could. Here. Let me make sure I'm not going too far off base here. I'm going to try and follow along with the textbook a little bit here, but it's pretty short. Yeah, push, pop, peek is empty. Oh, clear, you could clear off the stack, right? Clear's the tricky one. Right, just removes everything. That's void. Yeah, we could count the items if we added to the stack, sure. We could. We could. Push, pop, peek is empty, clear. Yep. All right, cool. So let's write a stack interface. Sure, maybe we'll call it stack interface. I don't know why not. Interface of type T. And yes, it's upset with me because I changed the name. Yes, we want to rename the file. Stackinterface.java. Perfect. You might just need to refresh, Rishi, or make sure you're looking at the 2353 repo. I've got several repos this summer. Here, I can even link you to it. I can post links here in chat. Look at that. It doesn't yell at me. No auto mod. Right, so a stack interface then, right, was going to do the things that a stack does. Right, so if it's of type T here, right, we'll have public void push T item. We'll have a public T pop. We'll have a public T peek. A public, boolean is empty. And a public void for clear. Right, that's our stack interface. Push, pop, peek is empty and clear. Right? So these push and pop will modify the stack. Peek will just look at the top item in the stack. And is empty and clear are just telling me about the stack. Telling me about it or clearing it all off here. Okay, so different ways we can use the stack. Alright. Cool. That was a format? Okay, spaced them all out. That's fine. Sure. So then there are obviously ways we can implement our stack in some different forms. We'll take a look at those in the next chapter. The rest that we're doing here with stacks is looking at a couple of usages for stacks here. And oh my goodness, there's actually a stack class in the Java library already. But, we can write our own because it's fun. Again, all these other things are in the library because people have looked at these before. The idea of why we study them and why we play with them and analyze them is to help us understand how they're used and make sure we pick the most efficient data structure for solving our problem. because the way that we store data, the way that we interact with our data is going to be different, right, depending on our different applications. So there's not always one right or one best data structure for a given problem. So stacks are great if you're doing something that you need a stack for. Right, so remember when we run our program in debug mode, you can look at the call stack. We haven't talked a whole lot about recursion, but we'll get to that. And that call stack gets to be really important. The idea is when you call a method, right, it calls, adds that to the call stack, and it knows where to come back to when it's done. Because it just left off here like line 26, it's waiting, and then it's going to run a method over here. That method might call another method, and that method might call another method, and on and on and on. And when it's done, it just goes back to the last method called in the stack at this line number and keeps on running. And that one's done, goes back to the previous method, goes back to the previous method. When we run out, when we get to the end of main, it's done, the program finishes. So everything just kind of gets to sit and wait in that call stack. There's another fun example in here of checking to see if your parentheses are balanced here, which is fun. So looking at our expressions, algebraic expressions, right, checking our different braces, essentially. So we might have a string, let's use a scanner keyboard, equals a new scanner, given system.in, and then we'll say, enter a bunch of code, oh goodness, and we'll check for balanced parentheses, or braces, balanced braces, right? Yes, import scanner. Now we have a string for code, keyboard.next line, and then we'll check. So we want it, so we can use this here, so we can have a method, public static boolean is balanced, given a string input. So it's going to make a stack here. Right, so we can have a stack, let's call it, this is a braces stack equals a new stack. This is of type char, here, oh, character, sorry, character. So a stack of type character here, called the braces stack equals a new stack, type character. Import from java.util.stack. Hey Blowfish, how you doing today? Now what we can do is we can go through our input here. So we can say for char character in input, no, input dot to char array. There we go, to char array. We can go through every character. And what we want to do is we want to say if the character, and now characters we can use equals here because they're actually the Unicode value. So if it equals a opening brace, right, or the character equals a open parenthesis, or if it equals a square opening brace, or the character equals a curly brace, opening curly brace. We want to push that onto the stack. So we're going to take our braces stack, and we're going to push the character. Okay, so if it's an opening one, we want to push it. If it's not an opening one, else if it's an ending one, we want to see if it matches. So we got to do these one at a time. So if it is a closing parenthesis, then we want to see if my braces stack peak, if peak equals the opening parenthesis, then we're going to take our braces stack, we're going to pop it off. So if it matches, right? If it matched, great, we found the ending parenthesis for the first parenthesis, right, for the starting parenthesis. If it doesn't match, we're going to return false. Okay, now our next case. If it's the closing square brace, let's see if it's an opening square brace. If it is, pop it off. If not, return false. The next case, if it's a closing curly brace, see if there's an opening curly brace. If there is, pop it off. If not, return false. if we've gone through the entire thing and we haven't returned false, we must be balanced. We're going to turn true. We can check if we're balanced. Peek just looks at what's on top of the stack, so it doesn't take it off. So it looks at it without removing it. So it just says, hey, what's on top of the stack here? And it's going to look at it. Sorry, my phone is going nuts. Forgot to put it on quiet here. Yep, okay. There we go. Oh, it's 7 o'clock. We're due for a break soon. So this is a quick little look at, hey, whether or not we're balanced. And we can print, your code has balanced braces. Plus, I don't know, is balanced. Given the code. That should be true or false. Let's try it. So if we enter a bunch of code, we'll check if we're balanced braces. How about, ASDF, parenthesis, curly brace, something else, curly brace, something else, parenthesis, more junk. It's balanced, right? There's a matching closing brace for the opening brace. There's a matching closing parenthesis for the opening parenthesis. Let's try it again. So if we have an unbalanced amount, so ASDF, how about a opening parenthesis or opening curly brace, parenthesis, curly brace, parenthesis. That is unbalanced. False. Okay. Well, no, let's see. Can we have just like a closing parenthesis? Ooh. Is balanced. We peek and it was empty. Empty stack exception. Oops. So no, we're not balanced. Okay, that's bad. So if we find a closing brace and the stack is empty, it's no good. So we can check first, I guess. So if stack dot is empty, braces stack dot is empty. No, is empty. My goodness, is empty. We can return false right away. Ugh, this is getting ugly now. But that should keep that from crashing, right? If we're empty. I'm not loving this. This is getting kind of ugly here. So that's okay. We're okay, right? It's not too bad. All right, so closing parenthesis. Not balanced. False. Okay, looking good so far. Now what happens if we have just say an opening parenthesis and some other stuff? Oh, we're not balanced and it says we're true. So we want to return my braces stack that is empty. Oh my goodness. Is empty. There we go. No, is empty. That one. Yes. So if we're empty, true, we're balanced. If we're not empty, we have a trailing opening brace that was no good. Right? That's no good. All right, I'm not loving this. I bet we could do better. Can we do better? We could probably do better. Oh, nice. A game console assembly. Sweet. All right, let's see if we can do better. So if it's a closing one of those, or a closing one of those, or a closing curly brace, then we'll check if we're empty, return false. Okay, so if we are a closing brace, great. If we're empty, return false. Then how about we have the, a char. Next is my braces stack dot pop. And if next equals this one, this was opening brace. So we found a closing brace, so we should expect to have a opening brace on the top of the stack. So if the opening brace equals this, and the character does not equal this one, we can return false. Those should be characters, right? Single quotes, right? So if it's empty, if we found a closing brace and it's empty, return false. Otherwise, well, give me what's on top. If the opening brace that we found on top is this, and the character's not that, return false. Else if the opening brace is equal to a square brace, and the character brace does not equal the ending square brace, oops, too much. Return false. Else if the opening brace is a curly brace, and the ending brace is not a curly brace, return false. What does it not like? Uh-oh. Oh, I did it again with the double quotes. These are single quotes. These are characters, not strings. Okay, so grab the closing brace. Right, it is a closing brace. If we're not empty, okay, get the top one off the opening brace stack. If the opening brace was this and it was not that one, if the opening brace was this and it was not that one, if the opening brace was this and it was not that one, great. Return false, return false, return false. Or, right, we can do even better. If that was the case, right, or this one is the case, or this one is the case, return false. Right, so if the opening brace was this one and the character is not that one, or if the opening brace was this one and the character is not this one, or if the opening brace was this one and the character is not that one. If any of those are true, right, any of those are true, return false. Okay, so that looks a lot better, right? With that little format, I probably don't need all those extra new lines. Does this make sense what we're doing, right? If we find an opening one, add it to the stack. If we find a closing one, if we're empty, we're out of balance. Otherwise, see if it's not a match, we're out of balance, return false. When we're done, if we're empty, we're balanced. We have a closing brace for every opening brace. This is essentially what happens in your IDE, which is actually really cool, right? If we don't have a match here, it does it line by line by line, so it's a little bit smarter, right? So it's like checking each start until it hits a semicolon, essentially, or for method headers. Compilers are pretty smart. And there's some really cool people who write compilers and work on compilers, and they help with that sort of thing. Oh, our little guy fell asleep. Look at his little face. He's the cutest little kitty. Alright. Anyway, it's a little after 7. We had some fun. This is like one thing you can do with the stack. Again, there's lots of things you can do with stacks. They're just trying to work through some of these examples where you push something onto the top, you peek at the top, or you pop it off the top, and you can tell whether or not it's empty. What language is the language that corrects Java written in? Like the Java IDE? NetBeans? I'm going to guess C++. I don't know. What language NetBeans written in? Does it say? It's open source. Here's a Quora answer. I don't know if you believe this or not. That's not an answer. NetBeans Wikipedia? This one says Java. NetBeans was written in Java. Huh. That's for Java. Written in... Oh, there we go. Written in Java. What do you know? People should only code in C. Oh, no, C. I mean, there's nothing wrong with C, but you don't have as much built-in stuff behind the scenes, right? There's tons of C libraries you can use, but it's not all built in. And it's made to be very compact. So if you do any sort of like machine level coding or embedded systems, you're probably going to be using C, that sort of thing, which is awesome. You can do some really cool stuff with it, but we're spoiled in that the Java virtual machine does a lot of work for us, right? It's a managed runtime language. C#'s the same way. It runs in the .NET framework or .NET Core framework. It's a managed runtime. Python as well. It runs in the Python interpreter. So it's pretty cool. All right. Yeah, choose what fits. You know, it's hard to adapt different languages depending on where you're working. Like if your company is already using one language heavily, it's hard to grab another because you probably already have all the built-in tooling. But you know, you can do lots of cool stuff with it. All right, anyway, we're due for a break. Why don't we take 10? We'll put on some music again, and we'll come back in a little bit.
I get lost sometimes and I can't seem to find a light between the walls I built for myself right in my mind. And then you came over and you showed me love that I never had seen before. And now when I got you, it's all gonna be alright. Thinking about all the things we did tonight. What a time to be alive. Just you and I. Just you and I. Only
Wendy's Frosty Chino is cold brew.
Hey folks, I'm back. How's everybody doing? Exactly just in time to get those ads. I think I got mute going just in time. So some other cool stuff about stacks that I've never been super into is infix, prefix, and postfix. Other ways you can use it to check for operands, those sorts of things. I wouldn't worry about it here. It's not too big of a deal. Okay. Yeah, we'll be in pretty good shape. Oh, okay. So he used a is paired method here. How fun is that? For checking the pairs. Okay, I didn't bother with that. That's fine. Think stacks have any implications in bioinformatics? I don't actually know much about bioinformatics at all. A lot of it just kind of, excuse me, depends on. Wow. Oh, definitely swallowed wrong. A lot of it just depends on the data. So if you are, yeah, I know Ariana Gunn, they're pushing her hard, looks like, but sure. If you have data that needs to be accessed in that certain order, that's what it's mostly about. Is if I'm reading data and I have to be saving it for something, but I'm only ever going to access the last thing I put, then you might want to use a stack. Yeah, I don't imagine you would use a stack for finding patterns, especially since to see what's the next thing in the stack, you have to destroy the state of the stack, right? You have to take the top thing off to look at what's underneath. So that's probably not ideal. Pattern matching has all sorts of other better ways to match for patterns and look for patterns. Yep. All right, so we'll look at how we can implement our own stacks then. Right, and sure, some of the operators, I find that stuff terribly boring, but maybe that's just me. Okay, so let's go take a look at some implementations in Chapter 6. Oh, excuse me. Now with a stack, the order definitely matters. Right, because you have it's a lot of times you might hear the term philo. It's first in, last out. Right, so and usually when we think of stacks, we think of them as like a bucket. Essentially, you put something in and it goes to the bottom. You put the next thing in and it goes to, well, on top of the next thing, right? On top of the next thing, top of the next thing, like that. So the first thing in is the last thing out. So philo. Or possibly last out, first in, lo-fi, but most people don't. I've never heard of that one being really popular. So that's it. That's all. Okay. So one great way of being able to store this data, right? And again, we're going to look at this in terms of performance here. Nope, not an interface. Sorry, we want a Java class. This is our, what do we want to call it? A linked stack. Linked stack. And it implements the interface. We can just click it here if we want. It's stack face. Look at that, stack interface. And then it adds the one word for us. How cool is that? I mean, that was not hard for us to type, but sure. Why not? And we'll say, hey, yes, please implement this interface. Implement all the abstract methods. Yes, please. We get a bunch of add overrides, and these are terrible defaults, but that's okay. Again, don't worry too much about it here. I'm going to do a quick replace all and just get rid of them. So let's Control H for replace, find and replace. All right, so and this is of type T here. Stack interface of type T here. So push is a T item. top gives T, oops, peak, no! Stop clicking that. T gives a peak, there we go. Okay, that's a little happier now. When it's of type T, we don't have to use objects. Okay, so pop, peak is empty, clear. Now for linked items, right, again, we have this idea of a node of type T. Public node takes a T item and a node next. Right, just like what we did with our ADT, our bag, our linked bag, we had this node here that had the actual item and then the next item here. Okay, and then we could write another one, sure, public node, given T item, and it just calls this given the item, and null for next, no next here. Right, so it has a T item, and a node next. So this dot item is the item, and this dot next is the next. Okay. And it's inner here, so making these public is probably not the worst thing in the world. I think we did that with the ADT bag. Usually having public attributes is no good, but this is a private inner class. Like no one else has access to node. It's only useful because we have a bunch of nodes that all point to each other. Right? This idea with this next is it points to the next one, and it points to the next one, it points to the next one. So these things are nice and quick here. So when we add an item here, like our linked stack here, then needs to know the top of the stack. So we're going to have a node of T, top. Right, that's the top of the stack. That's a private node of T top. Okay, so we have the top of the stack here. Okay. Then what we can do when we want to go push something onto the stack, right? It's going to go on top. It's going to be the new top. Right? So we're going to have a node of T, new node equals a new, I'll just call it node, I guess. So the new node of T given the item, and what comes after it is the current top. Right? And then top becomes the node. Right? So this idea here, if I have my stack going on here, right? We have a node with a T item, and next node, it could be nothing, right? Could be null. Could be something. It could be another node of T item, right, with the next. On and on and on, right? So if we're empty, right, my top is none, or null here. So the next item of the first node here then, so top has a T for item, its next becomes my current top. Maybe it's null, maybe it was actually pointing to something. We don't care. It's going to work either way. Okay? So that's how we push an item on. We make a new node. Its next is what used to be top, and now it's the new top. Peak is going to return top dot item. If we're empty, it's a bad thing here. So is empty. How do we check if we're empty? We're going to return top equals null. If the top is null, we're empty. If the top isn't null, we're fine. Right, so maybe we should add a constructor here. So we'll have a public, this is, what do we call it, a linked stack, T, it's just linked stack here, right? Right, the constructor's job is to set attributes, so top equals null. When you make a new stack, our top is null. Right, it as a reference value, this is explicitly happening, but it's good to be writing this out. So this is sort of redundant, but I'm a fan of always writing constructors, because your constructor's job is to give your attributes values. And maybe we'll move node down to the bottom, right? Put that down at the bottom as a private inner class. Again, some people say put your attributes at the top, and then your public methods, and then private methods, and this is essentially a private, it's a private inner class, but that's okay. So to clear, we'll say top equals null. And it clears it off. right? They'll all just go away. To pop then, right, we're going to have a, so we're going to have an item. Item is top.item. And then top will equal top.next. We return the item. I'm sorry, this is a type of T item. Return the item. So when we pop something off, we're going to take the top item. We're going to move top to the next thing, right? So if this was the current top here, we'll take this item off. We'll save it over here. And we'll say, okay, now top, you don't point here anymore. Now you point here, right? You point to top. Top's next. Once there's no longer a reference to this one here, remember, like the garbage collector is going to go pick it up. If we don't have a reference to it, it will be freed up, and the Java garbage collector can go take its memory and use it for something else. Give it back to the operating system. Okay? So all that's fine unless if we try and peek and we're empty, we're in an invalid state. Have we talked about exceptions? We talked about exceptions, right? Yeah, we did exceptions. Good. So we could throw an exception. That's probably best. So we're going to check if is empty. Is empty. We'll throw a new, I don't know what, empty, or what, invalid state. Oh boy, invalid. There's got to be something good in here, right? Invalid. What do we want to use? I'm trying to see what our author uses here. I want to steal off of him. Where's my... empty stack exception. Empty stack. Look at that, empty stack exception. Yeah. Add the import. There we go. There we go. So if we're empty, throw the exception. Same if we try and pop. Pushing's fine. Right, not a problem. I feel bad I have this twice now. So let's do this. Yeah, pop takes the top thing off the stack. Takes it off. Shrinks it by 1. I'm going to right click on this. I'm going to go to refactor, and I want to say introduce a method. Now check for empty and throw. Why not? Replace the duplicate invocation with the original method. Yes. Look at that. Check for empty and throw. It's a little private helper method, and it did it in both. Look at that. I'm going to move it down a little lower. Okay. We'll check for empty and throw. Check for empty and throw before we do this, because if we're empty, there is no top. Right? Top is null, essentially. Okay. Can you create a calculator using stack? Sure. Yeah. Right. Push them all on, and that's what the previous chapter was talking about, like how you can look at the notation. So when you find operators, you have to do certain things. There's order of precedence. You have to do certain things. I think I did it once as a puzzle. There's a ton of solutions out online though, so it's not the most useful assignment or anything. But yeah, you could definitely make a calculator using a stack. Because you have an operator stack and you have an operands stack. Right? Every time you find an operand, you add it. When you find an operator, you have to see if it's a greater precedence or lower precedence. Right? To see which one you need to do first, that sort of thing. It's sort of interesting, for sure. Okay, but this is our linked stack. So now let's take a look in terms of performance. Right, when we look at analysis of algorithms, right, all the stuff we did last week with that big O notation. There's best case, there's average case, and there's worst case. I can never remember how to point. I have to like twist my wrist really funny to get 3 to show there. Okay? So best performance of all of these. Well, does anything in here have to do with how many items we have in our stack? Right? Does pushing an item on care how many items we have? No. Does popping an item off care how many items we have? No. Does peeking care how many items we have? No. Is empty care? No. Does clear care? No. All of these performance is O of 1. O of 1, right? Constant time performance, all of them. That's for best, for average, and for worse, right? Because it doesn't matter, right? So best performance, right, is the best possible case. Well, it doesn't matter for any of these because none of them do anything n number of times, right? We never look at n items in our stack, right? There's no way to say, hey, what's all in the stack? Okay? Doesn't matter. It doesn't care how many items are in the stack. All of these operations are going to happen the same speed. So that's our time complexity. In terms of space, remember, nodes are a little bit large because you need a reference for the node. The node has a reference for the other node as well. So you're storing the memory address of the node, which stores the memory address of the next node for every item. And then you're storing the item itself. So you're storing an item plus 2 memory addresses. So it's not the smallest thing in the world. Okay? But that's a stack. That's a linked stack. Right? We could do it with an array. Right? We've looked at using linked objects, and we've looked at using arrays so far. Okay, so if we were to use an array, typically we draw arrays lengthwise. Right? We draw arrays like this, and we say, I've got indexes. Right? Index 0, 1, 2, 3, 4, 5, 6, on and on and on and on and on. Right? So we would say, well, where is fastest to add something to an array? Remember, adding to the back of the array, back CK, there we go. On average, do you remember how long this takes? Because we can do this arithmetic or geometric doubling, where we double the size of our array every time, and we say, well, on average, it's essentially still constant on average, but the worst case is it takes n operations because you have to make a new array of double size, right, and copy, right? Just copy everything over, and then you have more room in the next array. So, on average, it's still O of 1. Right? O of 1 on average. But the worst case here, right, is it's going to take O of n operations, because it'll have to do the doubling. It'll have to copy all n items out here. So we still got, on average, we still get constant time, thanks to geometric doubling. But it's not as great. But what's better with an array-based storage is you don't need to have 2 memory addresses for every node. Right? You just get, all right, here's going to be an array for my item. So here's a T, there are T references, right? So you just have the size, and you're a little bit oversized, right? So at most, we're storing twice as many. You know, so and at twice as many, that's the same number of memory references that the linked objects has to store. But as you get closer to being full, you use less than twice as many. So it's slightly more efficient in terms of space, if we talk about space complexity. All right, these ones are a little bit more annoying to write, though. Okay, so we'll do a new class. This will be our array stack. So array stack of type T implements the stack interface of type T. It says no, it doesn't. Would you like it to? Yes, please. And we'll do a little find and replace to get rid of these. Find and replace all. Awesome. I should just fix my template, but that's okay. Okay, so what it needs to have then is a T array for storage. Right, I'm just going to open up the ADT project here. Recent project. There we go, the ADT bag. Because we did most of this in our bag already. Not exactly all of it, but a very similar thing here with our bag array. Right, we're essentially tracking. We have a default capacity. Sure, we should do that. And that's a private key array for storage. Oh, I guess items, sure, items, why not? An array stack. Sure, we'll call it items. Now this is a array stack. Again, the size is great. If we know how many size, if we know what the size is, fantastic. Okay. Then what we also need is the resize function here. Resize, increase capacity, that's what it was. Increase capacity, we'll go steal that. Right, we're making new T items, which is my number of items times 2. Right, we're doubling, we're going to copy them over, and then we reset items to that. So then my bag array would, what was that? Increase, that was increase capacity. If, where'd it go? Yeah, okay, if my number of items, okay, cool. So to add something here, right, when you push an item on, we'll increase our capacity if we need to. If not, we'll set an item to my items list here, right, at the number of items, and then increase number of items. Okay, to pop something off, right, that was the same as our remove. Our bag array, we did a remove, took the number of items, right, removed it here. Where was our, that was our exception here. So empty stack exception. And yeah, we want to import that. So for empty, throw the empty stack exception. Now, if peak was different, right? We don't actually want to decrease the number of items. We just have number of items -1. And really, we can just return that, actually. Return items of number of items -1 if we're not empty. Again, this same sort of thing here. Okay, I'm feeling bad. Probably should be the same method here. What do we have? We called a check for empty and throw. I like that. We'll do that. But that does the check for me, right? Check for empty and throw. Okay. How's that one look? Is empty, right? So we return number of items equals 0. If we have no items, we're at 0. Now clear, right? Clear needs to remove all of the items. We could pop them all off if we wanted. Sure. Why not? We'll say while not is empty, pop. That should clear off this stack. Again, because it's going to go through, it's going to null each item out. Again, there's a little bit of returning here, but fine. I'm not too concerned about this. So now clear, right? How many operations that takes? That takes O of n operations, right? The more n items I have, the more things I have to go clear, because I have to null all of them out. Right? I'm removing all of the references so they can get garbage collected. With the linked stack, what's really cool here is if you take the top here, so if top is this one, the only way it knows what comes after that is because top has a next. So Java knows, hey, there's something that you have a reference to that references this thing, that references that thing. So we can have a bazillion things in our stack, and they're all referenced through that chain. If you remove your reference to top, none of them are referenced now, and Java can garbage collect all of them. So the garbage collection here is really fast as well with our linked stack, right? Those are all O1, but clearing our array stack, we need to go null every one of them out. So that's an O of n operations here. And this is O of 1 for empty. Peeking is O of 1, right? Accessing something by index, super easy, super fast. Popping something off, O of 1, right? Perfectly fine. Pushing something on, on average, here, it's O of 1. It's an O of n worst case. Worst case because of resizing, right? If we have to increase capacity, right, we have to do it. How's that feel? So we got two different implementations here for our stack with an array or with linked objects. I'm not using callable. I'm not sure what you mean by callable. What being callable? What? Yeah, please. Thanks, Ray. Right, and the last one they go through is the vector. I'm not a fan of vector. I think Arraylist is a little easier. But concurrent callable. Till concurrent callable. Returned result may throw an exception. Oh, like it's like a runnable. Oh yeah. No? I don't think so, because this is like, hey, this is something you can do. It's just an interface here. So his implementation with vector, it's a built-in Java class in the Java library for vector. It's essentially an array, but it's resizable, just like Arraylist. But so I think Arraylist is a little bit easier here than vector. Yep. So you can take a look at that one later. That one's not all that interesting. But the kind of the idea around that one is that the vector itself lets you do more things. So like if we had a vector in here, sure. Import until that vector, yeah, vector. Right, so we can make a vector of type string, sure. Strings, new vector of type string. So strings dot will give you all the things vector can do. Strings dot, come on. You can add to it, you can add at a given index. You can see if it contains. So vector itself has more functionality than the stack interface. But it does all of these things for us automatically. We don't have to reinvent the wheel. Like writing your own array stack, it's silly, don't bother, right? It's not worth your time. So if you really want a stack, well, I mean, you'd probably just use the java.util.stack. But if you wanted to use your own interface, right, we can essentially, it's called wrapping. We're taking a class that does a lot of things, and we're wrapping it in another class to change its public interface. To say, okay, the thing I've wrapped it with only has methods for push, peek, and pop. You can't do all of those other things. I'm only going to give you push, peek, and pop, but I don't have to reinvent the wheel. So you could wrap that way. It's an option. All right, a dad joke. You got it. Let me pull these up here for you. I only saved the best ones for you. Oh, yeah. So I was trying to get a quote for a new roof here. And I think the salesman I was talking to is also a dad. And, you know, we were talking about, we love telling dad jokes. And the more eye rolls you get, or the more ughs you get, the better joke it was. So I was asking him, you know, how much does the roof cost? And he said, oh, don't worry, it's on the house. And I said, oh, I think that joke's over my head. All right. All right, we okay with this? What? That's a good one. I like when those emotes just go flying on by. All right, so that wraps up stacks. We still need to talk about the interlude, polymorphism, and inheritance. That's going to take more than just a little bit of time. So I think maybe we take an early break and then we come back, or maybe we just make it like a 5-minute break. We'll do a quick one and then we'll come back, because I don't want to start and get halfway through, because it's going to take a little bit of time to get through with polymorphism and inheritance. So Why don't we take a quick break? We'll take maybe like 5 minutes or so. Is it okay if we just do a quick one, or do you want 10 more minutes? So I want to try and keep these like conceptually grouped together so we're not breaking in the middle if we can help it. And then we'll come back and we'll talk about Project 2 as well. So we'll have Inheritance Polymorphism and then Project 2 after a quick 5-minute break. I'm out of fluids anyway. I had to go get some more. Yes, polymorphism is, but Mizuki 2151 is not a required class for 2353 for reasons. Yeah, squad, exclaim YouTube. Yep, or you can also look at the VODs here on Twitch as well, but they only stay on Twitch for about 45 days because I don't bother to highlight them because I'm lazy. Although, I guess exporting YouTube is just as hard, but whatever. Alright, we'll take 5 and put some music back on. I'll go get some more beverage. And we'll be right back. Oh, it's on. I'm on mute. Watch out. There it goes.
We got pulled into We spent our days on the coast of something beautiful. We got pulled into the tide of something real. But somehow I lost you on the way. I assumed you left me behind. Lifeless days and sleepless nights, so tired of it. I can't get you off my mind, can't forget it. Now I know what I've got to do is find my way back to you. Why did it take us so long? While I was dancing on my own. And now my prayers get answered in my darkest time. 'Cause now I found you. I was waiting on the day you would come back to me, hoping that I didn't burn a bridge I couldn't see. And now that you're by my side again, I'll never leave you behind. Lifeless days and sleepless nights, so tired of it. I can't get you off my mind, can't forget it. Now I know what I've got to do is find my way back to you. Why did it take us so long? While I was dancing on my own. And now my prayers get answered in my darkest time. 'Cause now I found you.
Hey folks, welcome on back. Alright, probably close that down now. Alright, so we're going to spend a little bit of time here on inheritance and polymorphism. So not too long here, but we'll pick up a new project here. Look at inheritance and polymorphism. There we go. Yeah, hopefully it's a review from, if you have it from 2151. We don't go super crazy deep. We're going to look at a couple uses here and things that we can do with it. Right? We've already kind of done a little bit of that with this shopping cart. Right? This idea that it will take a type of interface here means that any class that implements this interface polymorphically will fit, essentially, or will be accepted here because it is a bag interface. Right? When you implement the interface, it creates the is a relationship. You are one of those. You are other things as well, but you fit the contract here for that interface. Okay, so one of the basic ideas, right, with inheritance is that it creates an is a relationship. Right, that idea that this class is a type of the parent class that it's inheriting from. It is one. So inheritance is not always appropriate. And depending on what people are doing, we run into all sorts of weird issues where people try and use inheritance when it really doesn't belong. Right? I've given some projects after we talk about inheritance, and people do some really funky things with inheritance. So it's not always the solution. Definitely not always the solution. But it is very useful. The idea is it creates a specialized version of that parent class, and we'll do something special with it. Right? Okay. So let's do this. Let's make a class here, and we'll call this one. I use it a lot, but it's okay. It's a polygon. So polygon has a private int for number of sides, and a private int array for side lengths. Right? This could even be an array list if we wanted, or an int array. I don't know. Int array is probably fine. Usually array lists are nicer, but this is pretty basic here. Okay. So what we're going to do is we're going to add a constructor here, then that you tell me the number of sides here, and I'll make side lengths equal the new int array of size number of sides. Right, and then we'll add a get method here. We'll add a getter for number of sides, so you can get the number of sides. Okay, so now we need a way to set the side lengths. So we're going to have a public void set side length, given the int side index and the int side length. You tell me which index, and I'll go set it to my side lengths. So side lengths of side index will assign the value of side length. Right? So we'll set my side lengths array at the given index to this side length here. And this one is already going to throw an exception if you give me an invalid index. Right, it might be nice to check, but I know it's just going to crash anyway with an index out of bounds exception, so I don't really care too much one way or the other. And a public int get side length given an int side index. And it's just going to return this one here. We'll return the side lengths array index of side index. Okay, so we got some public methods to interact with it. And then another cool thing we can do is we can return the perimeter. We'll call get perimeter. Perimeter? That sounds right. And so we'll have an int perimeter, starts off at 0, and for int side length in side lengths, we'll take the perimeter plus equals side length, and then we'll return the perimeter. Okay, boom, done. Easy. Right, we know how to do all that. No big deal. You okay so far? So this is Polygon. Now we can make a special version of Polygon. Right, we'll call this, how about a rectangle? Rectangle here. And we'll say rectangle then extends Polygon. Right, extends is our keyword for inheritance. It creates an is a relationship. It is a polygon. Now, right off the bat, it's going to complain at us because Polygon has a constructor that needs a number of sides. Rectangle doesn't have that. So I'll see in my notification, where's my error? See it here. Why is it not showing me? Windows. Oh my goodness. I'm going crazy. Why isn't it showing me? Whatever. So I'm missing it. Tikusa, sorry, the links don't work here. You could post it in the Discord. So we're not going to be able to make a rectangle here. So if I try and make a rectangle, rectangle equals new rectangle, it's going to be unhappy with us. Because rectangle is a polygon, but polygon has a constructor that needs a number of sides. I'm looking for that red line and it's not giving it to me. Oh, that's fine. If we just run, it's going to fail. There it goes. This is what I was looking for. So public class rectangle extends polygon. Required int found no arguments. Actual and formal arguments length differ. So rectangle can't compile because polygon has a constructor. So we need a constructor for rectangle here. But we don't need to know how many sides are in rectangle. We don't care because we know a rectangle has 4 sides. So we're going to call our superclass constructor. So super means the superclass here, and we're going to pass it 4 sides. Maybe rectangle takes an int for width and an int for length. Length and width, right? We could do that, sure. Oops, no, not there. Right, we could take a length and width, or maybe we don't, right? That's fine. Maybe we'll have a set length and set width. Public void set length. And a public void set width. Sure, we can do those. Now set length and set width then. So lengths need to set side length 0 and side length 2. It needs to set the pair. Which we'll call set side length of 0 with, oh, sorry, this should have an int for length and an int for width. For the length, and it should do the same for set side length of 2. Width should do the same thing, but for 1, right, 1 and 3, setting to the width. Right, so we were saying, okay, you can set a length, we'll set them in pairs, you can set a width, we'll set them in pairs. Now the problem is, though, I can make a rectangle now, but now rectangle, rectangle, dot, and we're going to see there's a bunch of methods here. I still have a set side length method. Nothing says I can't call set side length. So we've got a problem. So what we need to do here is we need to actually override that parent class behavior. So we add an override for public void set side length, given an int side index and an int length. Also, the polygon had a number of sides and then side lengths. So if we said, hey, it's a 10-sided polygon, we could set 10 different side lengths. For rectangle, we say we're a 4-sided polygon. You can have a length and a width. But now we also need to override set side length behavior because we need to make sure that you can't set them individually. We're going to say if side index is equal to 0 or side index is equal to 2, we'll call set length, given the length. And if side index is equal to 1 or side index is equal to 3, let's call set width, given the length. Okay, so we can use our own set length and set width methods here, just to protect against that. Right? We want to make sure that we can't use that other version. We want our version to run. Yep. We're going to see that in just a second. That's part of the fun. Okay, so we'll set the side lengths here. So let's add to polygon. Right. I don't know. We'll just get perimeter. So we'll spit out perimeter. There is, how about we set it to like 2, right? And then we have rectangle dot get perimeter. Oops, there we go. Let's give that a run. Uh-oh, stack overflow error at set side length, set side length, set length, set side length, set length, set side length, set length. Uh-oh. They're calling each other. Well, because set side length is calling set length is calling set side length. Set side length is calling set length. Set length is calling set side length. Run into a problem. So what we need is the superclass version here. So we're going to say super dot set side length. We want the superclass version of that, not my version. Because in this case, we want the polygons version here to run of setting side length. We don't want our version to run. Right? So we can say, hey, I really want the superclass version. I don't want my version. I want the superclass version. And now we get a parameter of 4. Parameter, right? Sure, and then we can even do a set width, right? Rectangle dot set width. Say, I don't know, 4. So we should have perimeter then of 12, right? 4 plus 4 plus 2 plus 2. That sounds like 12. Perimeter is 12. Awesome. And then other things rectangle know how to do. Rectangle should be able to do. How about public int get area? We can return get side length of 1 or 0 times get side length of 1. Right? Length times width. That's my area. Area is rectangle.get area. Okay, we can run that. Now we get a perimeter and area. Cool. So how about we do have like a toString here? So we'll add an override for public string toString. Okay, let's return polygon with, we'll do string format here. Format, %d digit sides with a perimeter of another d digit. So that is side number of sides and get perimeter. Okay, that's a little long there, so we bump that down. Okay, so we can return a string format. So now we can just toString it here, which is pretty nice, right? So we can just throw the rectangle in here, and we'll get that out. And now we get polygon with 4 sides and a perimeter of 12. Oh, well, polygon. Oh my goodness, can't spell. Polygon. Well, maybe I don't want that version, right? What if for rectangle then, we say we're a rectangle with a perimeter of, get perimeter, and an area of %d, get area. Let's whack the parenthesis there. Okay. Right, so we're going to change that behavior. Too many. Get perimeter, get area. There we go. Okay, so we can make a rectangle. We should be able to get that out. We should make a polygon. Get polygon out. Polygon equals a new polygon. Given, I don't know, let's say 3 sides and set side length. How about, nope, I want set side length. I don't know, 0. How about let's go 1, 2, and 3. That's probably not a very good triangle, but that's okay. Posture check. Thank you, Professor Perp. I'm slouching like crazy here. I'm gonna hurt myself. Oh, goodness. All right, how's that? Is that looking better? All right, awesome. And then we should be able to print out our polygon as well. So let's out the polygon. Give that a run. Okay, polygon, 3 sides, perimeter of 6, rectangle, perimeter of 12, area of 6. Cool. Now let's do one more. Right, let's do another. How about a square? Right, a square is a, right, it extends rectangle. Oops, that's not right. Sure, it does all the things rectangle does, but what makes it special, right? Well, its length and its width are the same. So maybe we need some add overrides. For, like, void set side length, given an int side length index and an int length. So maybe it should call set width of the length and set length of the length. Set the length and the width to the same. And then we probably need to add override our public void set width. Oops. Int length or width, sure, why not? Width th, there we go, makes it override happy. This is why those are so nice. They warn you if you're doing it wrong. And a set length. Length. Right, we don't even care what the side index is. The override gives you compile time checking, so I don't typo this and think I did it right. I'm going to get a warning here at compile time saying, oops, you're not actually doing the thing you meant to do. So it's super helpful to have. Like, it's your, hey, I really want to override this thing, and if you screwed it up, like I do all the time, it's going to tell you screwed it up. Some super handy checking. Yep, so then what should set width do? Well, really we want, like, super.setWidth here, right? Super.setWidth. Sure, why not? Well, sure, we'll do the exact same thing, right? Now just with width and with width, with length and length. Sure, they all do the same thing. All right, well, now I'm feeling silly. We might as well just call one of them here, right? We'll just do our own set length given the length. There we go. Slightly less duplicate code here, right? Okay, yeah. I like it. We'll set length of that one too. Look at that. We saved 2 lines of code. We have no duplicate code. We feel better about ourselves. No need to feel bad about yourself because you had duplicate code, right? You don't want that. Okay, so we should be able to make a square. How about a square? Square to square equals a new square. You know what? I would like if square had a constructor. How about that? What if square had a constructor? Look, square that took an int length. And it just called set length, given the length. I like that. That just makes it easier to use, right? So I can make a new square of 4. And we can S out our square. Oh, but we probably want to change our toString as well then, right? Let's do, hey, I'm a square, the perimeter and an area. So overrides, they give you compile time checking, so that if you typo something, it's going to tell you, oh, you're not actually overriding anything when you go to build. Build. Oh my goodness. Build. It's in there, right? I get an error because my override here. So you get compile time checking. That's the huge bit here. So it's like a safety check. Like, I really want to override this thing. Please make sure I'm actually overriding the thing. Just to make sure you didn't typo. Everybody typos all the time, right? Don't feel bad about typos. Hey, Professor Perp, thanks so much for donating your bits to the Student Scholarship Fund at the University of Michigan Dearborn College of Engineering and Computer Science, where I'm both a lecturer and a student. Yeah, it won't compile if you misspell override. Yeah. Sure. We get polygon, we get rectangle, we get square, we get the right ones here. Now the fun part here. Now that we have these, I can make an array list of type polygon. Shapes equals a new array list of type polygon. Oh, really? I can just use diamond here, right? And I can say shapes.add. I can add the polygon. Oops, import the array list. Yes, please. We can add a polygon. We can add a rectangle because it is a polygon, right? It's polymorphically treat it as its parent type. And shapes.add a square. I can add a square. And then I can say for polygon shape in shapes, let's S out a shape. Right? System.out.println. We'll print line. This should call toString here. The amazing thing, what happens here is at runtime, even though we're treating it as type of polygon here, while it's running and we call a method like toString, it says at runtime, well, what type are you actually? I know you think you're a polygon, but what are you really? Right? What special type are you? Are you a rectangle type? Are you a square type? What's your special version here? And if there's an override, right? If we're overriding that behavior, we'll get the correct version here. Right? Not only that, is we can ask for side lengths, right? So we can say enter side length for side 0. And we can call shape.set side length given index 0 of, okay, well, we need that, sure, why not? Let's, we'll do scanner keyboard equals a new scanner given system.in. Sure. Add my import, yes, please. And we can say int length equals integer.parseInt given keyboard.nextLine. And we'll pass in that length. Okay. Can you show the polygon toString again? Sure. So it says, hey, I'm a polygon with %d sides with a perimeter of %d, and we substitute in number of sides and get perimeter. Rishi, am I putting you to sleep? Is this too boring? I'm sorry. No, the %d's here are number of sides and get perimeter. And we have a get perimeter method here, and number of sides is our attribute here. Number of sides. So when square gets called, we just say perimeter of get perimeter and area of get area. Yep, so here's the super cool thing. When we call set side length, and then we'll print out the shape here, we're going to see it should work. Because it's going to run the correct set side length version here. All right, so for our polygon, let's say, I don't know, let's do 10. For our rectangle, right, so its perimeter was 6 because we had 1, 2, 3, right? And now it went to 15 because we changed the first one to 10. Yeah, it'll call the correct methods in the subclass, even though we're treating it as its parent type here, as being an array list of the parent type. We get the correct versions here. So we're with rectangle, where my output go? Here it is. It used to have an area, a perimeter of 12 and an area of 8, because we said rectangle with 2 and 4. So we're going to set the 2 sides here. Let's go with 7. So 7 times 4 should be an area of 28, and 7 plus 7 plus 4 plus 4. 14 plus 8 should be 22 for a perimeter. Perimeter of 22, area of 28. Awesome. Our square, let's go with 11. We get a perimeter of 44 and an area of 121. All with a single call to set side length because this version has been overridden. We get the correct operation here happening, even though we're treating them polymorphically like their parent type. Okay, cool. There's also, if you wanted to be able to set side lengths directly, right now it's private and you can't touch it. If we wanted to, we could change this to protected. Remember, protected is that middle of the road access modifier that says me and my subclasses have direct access to this. So protected gives access to child classes. So it's like parent class and child class, superclass and subclass, base class and derived class. I don't know why there's so many terms for it. People use them all the time. I like superclass and subclass because we use the super keyword, but most of the time I call it a parent class because that's what I think of it, even though I probably should call it a superclass because we use the super keyword. There's no parent keyword, right? There's a super keyword, so we should probably use superclass and subclass. But again, sure, why not? Okay. Let's do another thing. Let's do this. So when we're treating them as their parent type, you'll notice I get shape dot. All I get shape dot is number of sides, perimeter, side length, set side length, and toString. There is no set length. There is no set width, right? Because those methods don't exist. There is no get area because that method doesn't exist in Polygon, right? So if you want to have a class that's designed as a parent class, that you're sharing a lot of common functionality, and you want to have your child classes, subclasses implement that method, we can declare it as an abstract class. So we say this is an abstract class, Polygon. And then what we can do is we can have a public abstract method here int get area. So an abstract method is very similar to an interface method. It's saying you have to have this method if you inherit from me. But what's cool at abstract classes is you can have some functionality mixed and matched with abstract, where interfaces, all you get is the abstract methods, essentially. So like an interface is essentially a purely abstract class with just methods, but you can implement as many of them as you want. You can still only extend from a single class, even if it's abstract or not. So now, rectangle is fine because we have get area. Square is fine because we have get area. But what that means now, because it's abstract, we can't make one. If a class is abstract, you can't initialize it or instantiate it. So we get a warning here that we can't do that. All right, sure, no big deal. But what that means now down here is I can say shape.getArea, because getArea is now a method defined in the Polygon class. Okay? So we can use abstract classes and methods to force the child classes to have certain versions. It's pretty cool. We okay so far? Again, hopefully it's all review from 2151. If you hadn't had the class yet, it's new, and that's okay. No big deal. Don't worry about it. Well, we don't have a polygon. That's right. Polygon doesn't exist. Everything else should work just fine. You still get rectangles and squares. 10 and 10, sure. Okay. All right, cool. So that finishes out that interlude. Let's talk about the next project. Let's do project 2. So this is due in 2 weeks on the 16th by 6 p.m. Let's make a new grade in projects. All right, so we're going to use a stack in this project. We're not going to write our own stack, right? Because that's silly. We can just use the stack. But the idea is we want to come up with a way that we can use the stack in a way that's going to make sense here. Okay? So what we're going to do is we're going to write a simulator for a game of war. So war is a pretty basic card game. War card game. right? Let's see. There we go, Wikipedia. So 2 players, typically, using a standard 52 card deck, essentially. Right? The idea is each person has their own set of cards, right? You take the deck and you divide it between the players, and they each get a stack of cards. They reveal the top card of their deck. The player with the higher card wins. If they're a tie, that's a war, so you get 3 cards down and another card up. Sure, I always did 2, I guess it's 3, who cares? 3 down, 1 up. The highest face-up card of the war wins all of the cards. If they're tie again, you repeat and repeat and repeat. In our case, if you run out of cards, you lose. Right? I think that's fine here. Okay? For war. Now, but what we want to do here, so we need a class for card that is comparable based on the face value. Okay? So we need to be like saying, hey, player 1 plays this, player 2 plays this card, and showing the results here. And a toString method to display the suit and face, or face and suit, right? And suit of the card. Display both players' cards and say who wins. Right? Does player 1 win? Does player 2 win? If there's a tie, there is a war. Tie. War happens. And 3 cards are played. And the 4th is used to determine the next winner. Right? So there's no like face down idea here. Just be like, okay, player 1 plays 1, 2, 3, 4 cards. Player 2, 1, 2, 3, 4 cards. And we're going to check those 4th cards. Okay? Now what we want to do here is we want to randomize this. Here, so we're going to create a deck of cards to deal each player's hand, or each player's stack of cards. Be sure to shuffle it each time. And then what we're going to do is we're going to see if we can find some sort of relationship or some sort of average number of turns based on how many decks of cards. Okay, so we're going to run the game 100 times and see, and count the number of turns it takes to finish the game. So like how many turns happen before the game is finished. Right? So what happens here, right? Our players have stacks of cards here. Let's go down here. Right, so you have your stack of cards here, right? Your card, your card, your card, card, your big stack of cards. They have their stack of cards here. When you play your top card, they play their top card, right? Maybe say mine was a 2 of hearts, and yours was maybe a queen of hearts. So you're going to win. So it's the total number of turns it takes to finish the game, and then average, calculate the average. The average. And we're going to repeat with different numbers of decks. 1 deck through 10 decks. And then display the deck count and average turn count at the end. We're going to see if there's some sort of relationship between the average number of turns and the number of decks that we have. And I mean, we're definitely expecting it to increase, but are we going to expect, is this going to be like a linear kind of increase where you get double the number of turns for every time you double the number of cards? Or like as we increase the number of cards, are we getting some sort of more of a quadratic curve here that you're going exponentially larger number of turns as we go to see? Okay? Shuffle it each time. So don't start with like 52 cards in order and just give them out, right? Make sure we shuffle them first. So there's a, what is it, Java Arraylist shuffle. Yeah, there's a shuffle, collections.shuffle you can use. right? So use collections.shuffle. Where's that here? Here we go. Let's see, collections.shuffle. Okay, collections.shuffle. Is that a capital C? Probably a capital C, collections. Yeah, capital C collection dot lowercase s shuffle. Shuffle. All right, so anyway, so you play the cards. When you win, you get both of these cards in your, you don't add them back to your stack here, right? Because this is a stack. There's no way to add to the bottom of the stack. So you just add them to a pile here. Your pile. When your stack is empty, you take your cards in your pile, you should shuffle them. And then put back into a stack. So you're playing a card at the top of the deck, not just a random card in the deck. So you take the deck of cards, of 52 cards, you give 26 to this player, you give 26 to this player, right? Or you shuffle. Shuffle the 52 cards. Give 26 to this person, 26 to this person. They each play their cards in war, right? So there's going to be 26 turns, unless there's a war, right, which it counts essentially. But sure, they'll play 26 times. They'll get a bunch in their pile. When their stack is empty, right? When the stack is empty, shuffle the pile and put it back into a stack. Right? So this is probably also an array list, your pile here, right? So put the cards you win, cards each player wins, into a pile array list so you can shuffle it when their stack is empty. Okay? So then we're going to create a class for player. Right? So card, right, has a class. There's a player class. There's a deck class. Right? And we'll deal the card from the deck to the player. Right? Deal cards from the deck to the player at the start of the game. When the player's stack is empty, shuffle their win pile and put back into the stack. Right? The only thing you do with the stack is you push or you pop. We're never peeking. We're going to push or we're going to pop for the stack of cards that the players have. Right? So when we deal cards, we need to push them. When we shuffle our win pile, we need to push them. Right? But when we play, we're going to pop them off and compare, see who wins. Right? Counting the number of turns that it takes to finish the game, calculate the average with different decks. So 1 deck through 10 decks. So the deck class then might say, hey, how many decks of cards am I? Am I a single deck? Am I 2 decks of cards? Am I 3 decks of cards? Am I 4 decks of cards? On and on and on and on. And I definitely suggest you use enums for card. Use enum for face and suit for card. Oops, Control S is the wrong button to press in D2L. All right, so we need a rubric here. We got a little bit going on here. That's okay. So let's can I grab all that? There, good. Let's make a new rubric here. This is project 2. There we go. Project 2. Okay. Delete, delete, delete. We have missing or complete. 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 There we go. Okay, so a card class with we should implement comparable interface, probability interface. So you get a positive number if you're greater than, you get a negative number if you're less than, or you get a 0 if you're equals to. So we're only looking at the card face here when we compare them here. And then we have the deck class with various numbers of decks. I think that should go here. Card class has enums for face and suit. Your deck class with various number of decks. Your player class with a stack of cards and an array list of 1 cards, or for array list for the win pile. Right, and then player class. The stack is empty. Shuffle the win pile and put back into the stack. And then the simulator runs 100 times, counting number of turns until someone wins. Averages the number of turns. The example that we did in class for project 2. Sorry, Harishi, which one? Okay, so our card class, deck class, player class. Let's see. What do I have here? Got them all right. Comparable. Yep. Class player, deck class, display. If there's a tie, put them into the pile. Simulate. Okay, I think that's all. And then simulator runs for various deck sizes, 1 through 10 as well. Let's see, we got to add some more points here for some of these. So let's do custom points on this that we did in class today. Which, you mean the stack? I would just use the java.util.stack. I mean, using one of ours is, sure, you're welcome to use ours. I don't care which stack you use. There's one already written for us, right? It's fun to look at them and kind of analyze why they're fast, that sort of thing. But I don't really care which one you use. Okay. Deck class variable text can deal cards to players. Can be dealt cards from the deck. Or I don't know what can cards to the stack from the deck. Or the win pile. I don't know if that makes any sense. Exclam GitHub, I think, Professor Perp. Or my repo link. Let's see. All right, so 7 of those. Let's do like 3 points for this one, 3 points for this one, 2 points for that one, 2 points for that one, 2 points for the deck class, 1 for enums. What does that put us at there? It's at 14. 2 for the card class, I guess. And that puts us at 15 points. I like that. 15 even. Because the first project was worth 10. And this is, we're doing a little bit more than the first project. So this is, the overall score thing is nonsense. There we go. So it'll be 15 points here for that one. That's 6 p.m. There we go, on the 16th in 2 weeks. All right, that should be out there. Oops, I got to change that. Not a file submission, sorry. Let me go edit that. So you want to give me a text submission here. Oh, let me go to my classroom and get that link here for your GitHub repo for project 2. Okay. Please submit the URL to your feedback, pull request, and a self-assessment using the rubric. All right, there we go. All right, questions, thoughts, concerns? Again, so the game of war itself is not overly complex, but we're trying to see how a stack could fit into this, where we're going to add stuff to it, we're going to take stuff off, that sort of thing. There's no way to shuffle the stack, so all the shuffling you're going to want to do in the array list of deck or the array list of your win pile. Right, your shuffling needs to happen there. If you don't shuffle, there's actually a chance that your game will never finish, because things happen just right that you get cards in the exact same order over and over and over and over again. So the shuffle step is really important. Otherwise, things are probably going to get screwed up, and you might get stuck forever. So but run 100 times for each deck count, get an average number of turns, and then we're going to spit out, hey, for 1 deck, this was my average turns. For 2 decks, this was my average turns. For 3 decks, this was my average turn. No, there's no points in the rubric for the self-assessment, but I would like people to do the self-assessment so that they're looking at the rubric. Like I put a rubric in for every assignment, and I find sometimes people just totally ignore it, and they just, sure, whatever, and they're like, well, I don't know how I did. Well, look at the rubric, and look at your code, and you tell me, did you do it or did you not do it, right? And then you should have a pretty good feeling for whether or not you're successful. There's not a whole lot we can unit test in here. We could do unit tests on like card comparisons. Not too concerned. Again, that's more of a 2151 sort of topic, again, or even a 1500 topic for unit testing. It's a good habit, but you know our focus is on the data structures and using them and some of this performance thing. So we can just go from there. Okay? All right, questions, thoughts, or concerns? Or are we feeling all right? Ready to call it a night? Again, sorry, we're pushing almost 3 hours here. I'm sorry. This was a little bit long here. You know, hopefully we'll only go into just a little after 8, you know, 8, maybe 8:30 if I can help it. But, you know, nights when we have to solve a project are a little longer because we have to go over the project solution first. All right, so then next week we'll pick up recursion, generics, and exceptions. So recursion from chapter 7, generics and exceptions from the interludes. I didn't talk about exceptions yet? No, we did. Am I going crazy? We did exceptions. Yep, and I got to post the quiz. You're right. Thank you. Yep, I'll post a quiz as well. I think I posted it. Yeah, the chapter 1 through 4 quiz. Don't forget that's due by 11:59 p.m. tonight. I'll post a quiz for stacks, polymorphism, inheritance. Thank you. I got to write that down. As good as that worked last time, right? Post quiz for 2353. Stacks, morphism, and inheritance. Okay, thank you. All right, well, if we don't have anything else, we'll call it a night. Just for fun, we'll go raid somebody. See who's around. I think my friends are playing D&D, and I'm a giant nerd, so I want to go watch that. It's totally fine if you skip the raid. No feelings hurt at all. It's just for fun. But I think that's all I got. We'll be on a Discord if you have any other questions. And if not, I'll see you next week. Don't forget there is individual tutoring that's available. You can definitely take advantage of that. And we can go from there. All right.
Round.
Uh-oh. Where'd it go? It's kind of loading. There it goes. I have to go on mute here. Come on. There. All right. Awesome. Cool. I think I kicked it off. We'll head over that way in just a minute. It's been fun. You folks take care. If you have questions, thoughts, concerns, please let me know. We got office hours Monday and Wednesday, 3 to 4:30 and 10 to 11 p.m. So I'll be around tonight, 10 to 11 as well, and we can go from there. Take care, everybody.
With the family. Into the domain where the contract was valid, I would think that the power of